Problem 34. Find first and last position of element in sorted array. So for this problem, let's just try to use an easy way to solve it. So we are given an array of nums, and this nums is sorted in increasing order, and there are going to be some duplicate elements. So for example, 7, 7, 8, and 8. And we are given a target, and we want to find two values. Yeah, so we're gonna find the starting and ending position of a given start value. So for example, this value is 8, so the starting position is here, so the index is gonna be 3, and the ending position for this target value 8, so the index is gonna be 4. So finally, we're gonna return 3 and 4. And in the second example, there's no such target, so we're gonna return -1. And similarly for the third example, if we didn't find any target value inside of the nums array, we're going to return a -1. Yeah, so definitely this is going to be a binary search. So let's just write a binary search function, but we're going to use a write a bisect left function, or let's just name it maybe lower. Yeah, let's just use bisect left. So we're going to write a bisect left function, and we're going to have the nums and the target. So we're going to prepare the left and right pointer. It's going to be, for the right, it's going to be length of the nums -1, and let's just finish the binary search. Yeah, and we're going to prepare m going to equal to l plus r divided by 2. Now we want to check. Yeah. So if nums m is less than the target, so what are we gonna do? Because it is too small, so L gonna be updated to m plus 1. So else if nums m is more than and equal than the target. So for example, here, if this is the nums m, it is more than and equal to the target, which is 8. So this means, yeah, we need to go to the r pointer needed to go to the left. Yeah, because for the bisect left, we always want to find the first value which is more than and equal to 8. So this value is more than and equal to 8. So we're going to find this index, which is going to be 3. So what if we didn't find? So if there's no such value, 8. So for example, we find 5, 7, 7, and 10. There's no 8. So this means we're going to find the first value, which is going to be more than 7, so it's going to be index 3. But at index 3, this is a 10, this is not 8, so definitely we're going to return a -1. Yeah. And for updating the right pointer, it's going to be m -1. So finally, we're going to return L. So L going to be bisect left with nums and target. Then we're going to check the L. So if L equal to the length of the nums, so basically this means we didn't find it. Or nums L not equal to the target, this means we didn't find it. Yeah. So for example, if the target is 1 and this is the nums. Yeah. So if the target is 1, we want to find the first value, which is going to be more than and equal to 1. This target is 1, so it's going to be the index 0. So this means we can still find it. But if the target is 12, it's going to be more than 10. We're going to find the first value, which is going to be more than and equal to 12. Definitely, it goes out of the array. It's going to be the length of the nums. This means we didn't find it. Yeah, and also for this nums L, if it is not equal to the target, it means we didn't find it. So if we didn't find the left pointer, definitely we're going to return a -1 and a -1. So otherwise, this means we can find it. So we're going to set a right pointer. Yeah, so r going to be similarly equal to the bisect left with nums. And here we're going to use some trick. We're going to prepare a target +1. So for example, this target is 8. Yeah. So if we still use this function bisect left with this target 8, it's going to be the lower bound. It's going to be this index 8. But currently we want to find the rightmost index, which is going to be this one. How can we find it? So for the target, we're gonna plus 1. Currently this is 8. Now this is gonna be 9. Yeah, so if this is 9, we still use the lower bound bisect left. So it's gonna be, yeah, because we are going to find this target 9. So this is 8, and from here it's gonna be more than and equal to 8. So the index is gonna be this one. But this one is not right, so this means it needs to minus 1. Now the index is going to be 4. This is exactly what we need. Yeah, so this is just some trick. Finally, we just need to return the left and the right pointer. Now let's just run it and submit it to check if it works. Now as you can see, it works and it's pretty fast. Yeah. Now let's just try to, maybe you think bisect left is just library in Python, because in Python there's bisect left, bisect right. We can directly use it. So what about we just rename this function to lower bound. Yeah. So now let's just use the lower bound. Maybe this is better because bisect left is a Python library. Yeah. Now as you can see, it still works. Yeah. Now let's just try to remove this function, because we know this is a bisect left for this lower bound. Let's directly use a bisect left. Yeah. And here we're gonna directly use bisect left to solve it. Now let me just run it. Yeah, and submit it. Because this is a bisect left method, we just need to know how to write this. As you can see, it still works. Yeah. And as the bisect left works, so how about the bisect right? Yeah. So this is a bisect left with a target plus 1, and here we're gonna need to use a minus 1. So what if we directly write the bisect right? Yeah. So this is the bisect right. For the bisect right, we're gonna directly use the target. So for example, this is 8. The bisect right gonna find the first index for this value, which is gonna be more than the target. So it's gonna be this index. Yeah. So this means it goes out of the boundary. If it goes out of the boundary, it is here. But actually, what we are looking for is this 8. It is the index 4. So this means we need to minus 1. Yeah. So this is another way of writing. So from here, we file to the left. So if the left not exist, we're gonna return a -1 and a -1. If the left exists, we can find this value. Definitely, it's gonna have a right index, and we can calculate it directly using bisect right. This is also okay. Yeah. But for finding this value for the bisect right, we're gonna find the first value, which is gonna be more than the target. So it is this value, and then we're gonna return this index, gonna be 5. So 5 minus 1 gonna be index 4. It's gonna be exactly this value, what we are looking for. It's going to be index 4. Yeah. Now let me just run it and submit it. Yeah, as you can see, it also works and it's pretty fast. So from this question, definitely we learned binary search, and we learned bisect left, and we learned bisect right. And what is the meaning of left and what is the meaning of the right. Thanks for watching. See you next time.